Hello, lovers of physics. Today we're here with number 34, where we have two pucks, puck A and puck B, and they give us the momentum of puck A, or they give us the mass and velocity, so you can solve for momentum. And so once puck A hits puck B, some of the momentum is transferred, but there's still the same amount of momentum in the entire system. So you can solve for what the momentum in the B momentum of puck B in the X is. Let me just make it a little a little more neat for you there. So for X we're gonna use X of B we're gonna use cosine of the angle 37. And then for the y of b, we're going to use the sine of angle 37. And you can do the same for a. For x, do cosine 65, okay? Now, I know I've mentioned the conservation of momentum a little bit, but here I just want to show you what it means. It means that when puck A hits puck B, and they end up, you have to remember, the initial momentum is always the same as the final momentum, and so that means, in this case, for example, the y's are going to cancel out because the y momentum in the initial is py initial equals 0, okay? Because, of course, puck A is only moving in the x, which means in the final of y must also equal 0 as well. So I drew them in red here. The y's, they're going to cancel out, okay? For that reason, the conservation of momentum. And also, for because of the conservation of momentum, the x's are going to be equal. They're not going to cancel out, but the x momentum of A and the x momentum of B are going to equal the original x momentum of puck A, as we see here, which, as we solved for a little bit earlier, was 0.14 Newton seconds. Now, we can use our trigonometry, and we know that because of the conservation of momentum, we can use the momentum of B, cosine 37, and the momentum of A, cosine 65, and that's going to give us 0.14. But also, because of the conservation of momentum, if you subtract each other, they'll give you 0 because initial equals final. Okay, and that's what we just did with these signs. Now, with these equations, with this equation, what I did here was I just took the equation that I just wrote that equals 0, and then I just added PB sine 37 to the other side to make them equal to each other. And now what I'm going to do is I'm just going to divide. So PB sine 37 divided by sine 65, okay? And we're going to need that for later. But for now, just remember that. And sorry I erased what was in the right, just so I can have more room to write. Now, solving for the momentum of B in the x is going to equal 0.129 Newton seconds. Now you just divide by the mass of puck B, which is 0.05 kilograms, and that's going to give you the velocity, which is going to be 2.59 meters per second. Now you know that momentum of A is equal to momentum of B sine 37 divided by sine 65. That is the equation that I have here in the bottom left that I told you guys not to forget about, so hopefully you guys didn't forget about it. And so with that equation, when you solve, you're going to get negative 0.1, and you can put that momentum of puck A equal to the mass times velocity, of course, and you'll solve for velocity and get that it's equal to negative 4.016 meters per second. Thank you.